Bismillahirrahmanirrahim. Assalamu alaikum. I am Bushra Hossain. My ID number is 203-1346642. I am talking about my project of CSE332, which is a 16-bit ALU following ISA format with a control unit. In this project, I have used a 16-bit ALU and a 16-bit register and a 4-bit control unit, which will give instruction and will send signals to ALU what operation ALU has to do. Let's see the project in Logisim. This is the project. This is the register file of 16-bit which I have learned from lab. Let's again go to data path. This is the ALU of 16-bit which will do addition, subtraction and then OR operations. These are the 4 operations I will do in this project. And this control unit has a 4 output. Let's see the control unit. This is the control unit which have 4 bits of opcode, and it will give us a 4 bit of output. First bit is for register Write.En, which will store the result of operation which has happened in ALU. For in B invert, it will give us the B's 1's complement. C in will give us the B's on 1 complements plus 1 result, which is a B's 2's complement. And we know that for subtraction we need B's 2's complement. So we will use these 2 for subtraction, and we will get a 2-bit ALU operation for doing our 4 operation, because we know that 2 to the power 2 combination equals to 4 operation. So we have to do the select bit to 2. In control unit 0001 000, we will do addition. For 0001, we will do subtraction. For 000 0010, AND operation. 0011, OR operation. And the ALU addition and subtraction is an arithmetic operation, and an OR is a logical operation. These are the 4 operation we will do. 2 logicals and 2 arithmetic operation. In this logical operation and an OR, it will do AND and OR operation binary bit by bit, like A0 will do AND operation with B0, A1 will do AND operation with A1, B1, and like this B0 will do OR operation with A0, B1 will do OR operation with A1. Like this, it will do 16 bit by bit operation for logical, and arithmetic operation it will do the simple addition and subtraction for those numbers. In this project we have used 16 bits. 16 bits, we have used 4 bits for opcode, 4 bits for RS, 4 bits for RT, 4 bits for RD. RD will store the result of ALU operation. This is the total 16-bit result. And or add, subtraction, all this operation will follow this 16-bit instruction. We will do I will do our first operation. For that in register 1 I will store 7, and in register 2 I will store 5, and we'll do our first operation. Let's go to registers 1 I will 7, and register 2 I will store 5. Now go to data path. Let's give a clock pulse. After giving clock pulse, I can see that in register 3 it stores 000 C. C means 12. We know that in register all numbers are all numbers are stored in hexadecimal. Hexadecimal C means decimal 12, which is the addition, result of 7 and 5. Let's see the slide. Here also we can see 7 and 5 equals to 12, which is C, which is hexadecimal number. So in data path we can see that in register 3 I have stored the number of 1 and 2 daters addition number in register 3. Now for subtraction I have used 1, and I have stored the subtraction result in register 4. Let's give clock pulse again. I can see the 1 and 2 I have made the same 7 and 5. So the result of subtraction of 7 and 5 is 2, which is stored in register 4. And now for AND operation I have used opcode 2 and have stored the value in register 5. Now give again clock pulse. Let's see the result of AND operation I have stored in register 5, which is 5, and the AND operation will do the bit by bit operation. We know that first. Now I will give another clock pulse and we'll get the OR operation. OR operation result will store in register 6, and OR operation result is 7. 5 and 7, OR operation is 7. Let's see. Now I can see that the select bit has become 0 in ALU, that it will do addition. So the B and 1. A was 7, B was 5, which is 12 in result, which is doing addition for ALU 0 0. Let's give clock pulse 1. It has make 1. Let's go to ALU. Then let's see this. I have 7 and 5, and it makes 2's complement of B. Then I have used 1 and add 1, and I have got the result 7 and 2 for 2, which is the subtraction result of 7 and 5, which is 2, and that is stored in register 4. Let's again give a clock pulse. Now it's 2. For 2 operation I have given the operation AND. It will do AND operation. Let's go to AND operation. Here I can see that A01, B01 have do AND operation and get 1. A11, B10 have do AND operation and 0, we get 0. Again A21, B21, and we get the AND operation of and 1, which is 5, and that is stored in register 5, which is the AND, which is the result of AND. Let's give another clock pulse. 3 6 1 2. 3 means I will do OR operation and store the value in 6 number register. Let's see ALU. It has did the OR operation. This is the OR operation. It has did the OR operation 1 plus 1 or A0 and B0, or if we do A0 and B0 OR, we get 1. A1 B1, which is 1 and 0. If we do OR, we get 1, and A2, which is 1, B2, which is 1. If we do OR of A1 B1 B2, then we will get 1, which is 7. And data part we can see the 7 result is stored in 6, which is the result of OR operation. Then let's go to OR. Let's go to register. In register we can see R1 is 7, R2 is 5, R3 is the addition of stored the addition of R1 or R2, which is 12. R4 is the subtraction result of 7 and 5, which is 2. R5 is the result of R1 and R2 AND operation, which is 5. R6 is the result of R1 and R2's OR operation, which is 7. And this data path is giving the correct answer for all the four operations. So we can say that my project is successful in giving the right answer, for giving me the right answer. So we can say that this 16-bit ALU following IC format with a control unit is working correctly and perfectly for my four arithmetic or my four operation, which has 2 arithmetic operation and 2 logical operation. Thank you.